Okay, this is the first of the two examples that we need to go through for the maximum and minimum problems. So we're finding a point on the parabola of y equals x squared that is closest to the point 3, 0. So the first thing you want to do, you want to try and make sense of what this question is asking for, is to draw yourself your parabola x squared. Okay, then we're looking at the point 3, 0, so somewhere roughly around there would be the point 3, 0. Now what we want to do is we want to find the distance, and we want the distance that minimises from this distance to this distance. Okay, so what we're doing is we're finding this distance from to this distance and minimising it. Okay, so what we want to do is we want to find the distance between 2 points. So the formula that you use for distance between 2 points, if you can remember, looks something like this. Okay, now to make things easier, then we're just going to look at d squared, just because then we haven't got to worry about this square root. Okay, so if we want d to be the smallest, then d squared is also going to be the smallest at that point. Okay, because we're looking at distance, we don't look at the negative or the positive. Does this make any difference? Okay, so now we're going to substitute in the values. So this is going to be 1 point. Another point is going to be x squared. So basically this depicts any point on the line x squared. If you don't like using x, you can use something else. So we could use p and p squared if you want. Doesn't make any difference. So we're going to substitute in. So we end up with, which way around should we do it? Let's have this as our x1, y1, and this is our x2, y2. Okay, it doesn't really make any difference. So we end up with p minus 3 squared plus p squared minus 0 squared. Okay. Okay, so then we end up with this quartic. Okay, and you can multiply out if you like. So if we're multiplying out, don't need our brackets. So we end up with p to the 4 and then this, so p squared minus 6p plus 9. Okay, and we want this to be the smallest it can be. So in other words, we're looking for the minimum. Okay, so that means that we're going to differentiate this. Okay, and if I call this, then the notation will sort of work-ish a bit better. Otherwise we're going to have dd. Okay, so if we differentiate this, we end up with 4p cubed plus 2p minus 6. Okay, now we want to find out where this is equal to 0, because that's where we're going to find hopefully our minimum. And so then we're going to end up having to solve this. Okay, so in order to solve this, we're going to need a calculator, because it's not a nice easy one. So I guess actually you probably could do without a calculator, but we'll do it with a calculator just so that we know what we're doing. So all we're going to do is put that into our calculators and do solve. And then that will find all the values of p that give us a minimum. And what we'll probably find out is that we'll end up having to discard some because it won't be in the right place. So if we add a calculator, we're going to do solve. So we're going to do, no, I'm going to stick with x. So we're going to have 4x cubed, and what was it? It was plus 2p minus 6. And we want to find out when that is equal to 0, and we want to solve that for x. Oh, and I put a P of an A instead of an X. Okay, let's go back. So that needs to be an X. Okay, so the only solution we've got is X equals 1. So we didn't need to discard because that's the only solutions. So in other words, P equals 1. So that means that the closest distance we're going to have is going to be, we want to find the point, so that means if X is 1, then if we plug that into our equation, that means Y is going to be 1. So we found this to be our minimum, so the smallest distance between 3, 0 and our parabola x squared is just the point 1, 1. Okay, we know that's the smallest rather than the biggest, because if we pick another point up here, that would be even bigger, and then so on all the way up there. Okay.